homework from last night. You had these problems here. And number one asked you to do, I can't remember the exact wording. Somebody want to read that to me? Okay, find the areas of 3 squares. Can you try to shut that door? What else, Allie? Oh, okay, so 1A was just finding the areas. And so, obviously, this one has an area of 4 because it's not tilted. And then, by surrounding one of these, you could see that this green rectangle or square that I'm drawing has an angle of what?
Or you could just split it in like.
Yes, you could.
It has half.
So we'll go both ways, because these are both the same, right? So the other ways you could split it. In this case, it does split really nicely. They don't always, but that one does. So either way, with the method on the left, that green square has an area of 4, and each little triangle here has an area of 0.5. There's 4 of them, so you would take out 2 units. So this is 2, and this is 2 because each one of those little right triangles is 2 units. I mean half unit, so they add together to make 2. Suki.
Different way.
Yep.
So I inferred that for the big squares before, you would have to find the square root of that, and that would be 2. So that's how I found it.
So it sounds to me like you're saying, since you knew that this one was 4, right? These 2 here would have to add to give 4.
Yeah.
And they were the same size.
Mm-hmm.
That works too.
All right.
Because you were, but the problem I guess that you made, I suppose you assumed it was a right triangle and nobody told you that yet.
It didn't say, it said in the book that it was a right triangle.
Yeah. Oh, okay, so when you read the directions, I didn't hear that part. So if they tell you it's a right triangle, you can infer that perfectly. Right. If they ask you to verify that it's a right triangle, you would find the areas, and then you would go to the next step and say, since these add together to get the bigger one, you know it's a right triangle. So what you're saying is, since you knew the triangle was right, you could say 4 equals to the 2 squares together, and you knew the 2 squares were the same, so they each had to be 2. Yeah, that's fine.
Okay.
So there's so many ways to do the problem. So what was there a part B to that one?
Yeah.
What's part B?
Even areas from part A to show that the squares on the side of this triangle satisfy the
Pythagorean Theorem. Okay, so that might have been a little bit more confusing. Okay, so I want you to look back at yesterday, and I'm going to explain that. So yesterday we had this picture, and we figured out if you had a given area, you could take the square root of that to get the side length, right? And so, like, if the area was 9, the side length was 3. And in the problem, they write the Pythagorean theorem for you there, don't they? So I'm going to show you how you would do it here. So they want you to show, we'll practice with this and go back to that problem. A squared plus b squared is equal to c squared. So what you need to know is, in these problems, it's hard to see, but they have a little c here, and they have a b here, and they have an a there. That's really hard to see. But you can see it in your book. Like, that length is A, this length is B, and this length is C. Okay? So you're supposed to look at what the length of A is. And in my problem, A is 3, right here. B is 4. You see that? So you're supposed to get that information, and C is 5. And then plug it into this formula. I got 5 because the area was 25, and so the side lengths must be 5 times 5 to make the 25. So,
3, 4, 5.
say that again.
Is there a reason that it's 3, 4, 5?
It's true in a right triangle if the legs are 3 and 4, the hypotenuse is always going to be 5, but it's not always consecutive integers. That's kind of a special case.
Isn't it have to be like if you divide it by the same number and you get like a 3?
Yeah, but Allie, we're not quite there yet. So it's true. There's proportional triangles like that, and that's something that's interesting that we'll do later. So you're supposed to take the lengths and show that when you square each length, you would get the third length squared. Because that's what the picture shows, doesn't it? Like 3 times 3 is 9, and that was the area of one square. 4 times 4 is 16. 5 times 5 is 25. And it's true that this adds up to 25. So you're just showing that the square roots, when you square them, you get the same thing. Because remember, that little exponent means multiply 3 by itself, right? So in the homework, you were supposed to, it's a little harder in the homework. So in the homework, you're supposed to get the length of this side, that's 2. That's not hard. So that means, let me clean this up a little bit. We knew that this was 4, but this right here is 2. And that would be, and then this length here, what's that length?
1.4.
The square root, okay, so not the estimate, but the exact.
Oh.
Square root of 2, not, so an estimate would be about 1.4, true. And so that's the same as this one too, right? Because it's a square. In fact, this one too, right? All of those are the square root of 2. You see that? You don't? Well, you have an area, if I clean that up a little bit, you have a triangle, or a square, that has an area of 2, right? So each side has to be the square root of 2.
Oh.
From a couple days ago?
Yes.
Remember that?
Yeah.
Okay, and so what the book's asking you to do is to use square roots in this formula and show when you plug them into this formula, a squared plus b squared, you get c squared. Okay? So if you go back to yesterday's picture, that c was always the longest side. Okay? So the longest side here is 2. You see that from the picture? So A could be right here, and B could be there. They're both square root of 2. So you're supposed to show the algebra. If I square 2, the root 2, and add it to the square root 2, I should get 2 squared. This is going to make more sense when we practice it.
Can't you put it as 4?
Yes.
Or
So that's the first step. So this is 4, right? And this is root 2 times root 2. So what's root 2 times root 2? You guys, when you multiply a square, yeah, what do you get, Stanley?
I have a question.
Okay.
When you started like from 2 the square root of 2 squared plus 2 squared equals 2 squared, wouldn't it be 2 squared plus 2 squared equals 4 squared?
No, because I'm taking, so I'm going to erase this up again. So we now know some values here, right? We know that this length right here is the square root of 2. That's different than 2. And this is the square root of 2. you're taking the square root of 2 squared. So that is this. And when you multiply a square root by itself, it undoes it, right? So you just get what's inside. 2 plus 2, writing with my left hand here, is equal to 4. Is that true? And that only works for right triangles.
Okay, we'll just keep 13 first.
Just go all the way. I mean, it's not a big deal, right? So in a math proof, you usually show they're exactly the same. Numerically, you're right. So the reason, the why would be, what if the numbers, like you didn't notice right away, they added up? Like if it was 2 numbers that weren't small, then you would add them and check it. Okay. Okay, so that's what you're supposed to do. We're going to practice this, Isaiah.
So for equations like that, do you not have to put like the dot or like the squiggles?
No, because I didn't estimate anything. I used all exact values. Okay, so when we look at part 2, Allie, can you read me number 2? Good.
The triangle below is a right triangle. Show that this triangle satisfies the Pythagorean theorem.
The Pythagorean theorem. So this time you only started with that, right? And I had this built from the other class. So, in other words, you guys were supposed to build this. Like we've been doing over and over and over, all the squares. You know how to do that, right?
Yeah.
So, Ronnie, are you nodding your head no? Say that again. So, if you had to build a square, you take the side length. So this is going to be something that you would do on a test. You take this side length and you see that it's slanted, right? And it goes, to get there, you go like over 2, up 1, right? So to get the next side of the square, you would do the opposite, up 2, over 1, and then you would put in your straight line there to make a square to make a right angle. Okay, so now I went up 2, over 1, so I'm going to go over 2, down 1 to get my next square. So we practiced this quite a bit on the worksheet, the dot worksheet. Remember that? So your original problem, you had to put this, you only had the triangle in the homework, you had to put the squares in. You guys get that? So you should have had the squares because that's what we worked on yesterday. If you didn't, then you need to really go back and study because I'm going to give you a problem like that. That starts just with the triangle and it's not going to be an easy one where you have to make the squares and do all the work. So read the question again, Allie.
The triangle below is a right triangle. Show that this triangle satisfies Pythagorean theorem.
So we would have to show that if it's a right triangle, the area of this square plus this square is going to be equal to that square. Right? Like yesterday, right? That's showing using area to show that Pythagorean theorem. You guys, do you understand that?
Yeah.
Okay, so in order to do that, I have to figure out all those values. So this doesn't divide up nicely like the way Kat did the other one, so you have to kind of surround your shape and figure out the areas. So that green square has an area of 9, and each of these has an area of 1. So 9 minus 4 is 5. So this is 5, which means the side length is the square root of 5. That's the length of one side. That's the length of this side. Allie.
Well, like, say on the test I had with Pythagorean theorem, they draw the boxes. How is there any other way to do it without drawing the boxes to find the right?
Yes, but so we'll get to that. But right now, this is how you're going to do it. So the answer to the question is yes, but we're still working on area. So the bottom line is tomorrow, or this week, if you have a triangle where you can't just tell the length because it's not on the grid, the sides aren't on the grid, they're slanted. One strategy that always works is to just fill the square. Okay? So like now I'm gonna look at this square here, and to surround this square, I can get the area. And Allie, the reason is we're just trying to focus on area also. So that has an area of 16, right? And each one of these is an area of 1.5. So this is going to be 16, take away how much? 6. So this is 10. You get that? 9.
Wait, so, are you ever gonna give us any that's like 0.75 for the white space? Is it just gonna be halves or more?
So
Like,
I have some samples today, but right now we're going to stick with the, like integer areas. Okay, good question. This would be square root of 10. Do you guys know that?
Yeah.
Okay, and so then the third rectangle, it should be 5, right? And so just check it, right? That's the same size rectangle as this. It's the exact same size as the other one, right? So it well, because it's a right triangle, it has to be, right? If I asked you, is it a right triangle, you would check to see if they're equal. Okay, so be able to do both. So we can see it's a right triangle.
So if it didn't add up to 5, then it would be right.
Exactly. So back here, when we had this situation here, we had an acute triangle, and it didn't add up. So this one's not a right triangle, because 5 plus 9 doesn't equal, 5 plus 8 doesn't equal 9. The smaller two don't add to the bigger. Do you get that? That's how you know it's a right triangle. Hold on, just let me finish this, then we'll take questions. So then they said use the Pythagorean Theorem, right? So that's the Pythagorean Theorem with the picture. But the Pythagorean Theorem with the algorithm, the rule, using a squared plus b squared, that's what we're adding in today. So a would be, so remember c is the longest side, so that would be the square root of 10 squared. A and b are the same, right? What are they?
5 square root of
Square root of 5 squared, right? So this is 5 plus 5 equals 10. Does it work? Yeah, 10 equals 10, so you've just shown the Pythagorean theorem works. Okay, Catherine.
How is this, but if the area of the box is 10, I'm just confused on why the square root would be 10. Because isn't this...
So the square root of 10 is the side length, because the square root of 10 times the square root of 10 equals 10. Length times width equals area.
Wait, if the side length is 10, then...
No, the side length is root 10. It's not the same. It's square root of 10 is like 3 something.
It's like 3.1.
So it's not the same.
But why is the side the square root of 10?
Why? You
Oh,
guys,
because the area is...
why? She's asking why is the side the square root of 10? What's the answer to that?
Because the area is 10.
They want the exact, not the exact.
That's how you write the exact.
I get it. Instead of dividing 10 by 4, you just write the square root.
Right, that's the exact answer. There's not like it's not an integer. Like here, it's easy to say 5 times 5 is 25. But when we can't find an integer that is multiply itself to get the number, we use that square root symbol.
So when it's not a perfect square.
Yes, right. Okay, so let's formalize this, you guys. Let's put this into the theorem that some of you have done, some of you haven't. Everybody's done it a little bit in the homework. This right here is the Pythagorean theorem. So in a right triangle, so you have to have a right triangle. where the hypotenuse, so that word is representing the side that is the longest, which is also the side that's opposite the right angle. So usually you'll call it C, okay? If you have a right triangle, this rule is always true, okay? So we're going to talk about how to use that. So if you look at, I'm going to shrink this down a little bit. If you had a triangle like this, you should be able to answer yes or no and show me why with the algebra and with the geometry. So if it were on dot paper, right? If it were on dot paper, you would find the area of the squares to see if they add together to give the big square. If it's not on dot paper, you would use the algorithm that has the red star by it. So if you wanted to see if this was a right triangle, you'd start with this formula, and then you would put the numbers in and see if it's true. And I started with a really easy one. So 6 squared plus 8 squared. So I'm using the smaller two sides, which we call the legs of the triangle. And the long side we call the hypotenuse. Yeah, good point. So it wouldn't have it, that was just a mistake when I was drawing that. It wouldn't have it. On these you would have to decide. I just cut and pasted the picture that I was using on a different page and I forgot to take it out. So the question would be like that. Thanks, Kayla, that was smart. So you wouldn't see the right angle because you're trying to decide if it is or not. Okay, so then 6 squared is what? 36, right? And 8 squared is 64. And what's 36 plus 64? 100, and that's equal to 10 squared, right? So you would answer yes. You know, because the Pythagorean Theorem works. Okay? Now look at this one. Is this a right triangle? So the hypotenuse would be what? 5, right? So you would still be doing a squared, you would still be checking a squared plus b squared is equal to c squared. So you'd say, is 1 squared plus 4 squared equal to 5 squared? 1 plus, what's 4 squared? 16. 25. Is 17 equal to 25?
No.
No. So this is not a right triangle.
Trick us by the little thing in the corner.
Okay. Do you understand how the Pythagorean theorem can show that?
Yeah.
Okay, so they can get a little harder. First, let's just make sure if you don't have a picture, you do this by just knowing the theorem. You'd always take the hypotenuse to be the which side? The longest. So you have A, B, and C there, right? Work them out and tell me which ones, if any, are right triangles. Okay, so Nick, what'd you get for the first one?
The first one I got that it is a right triangle.
Okay, so how'd you set it up?
I did 9 squared plus 12 squared equals 15 squared.
9 squared plus 12 squared, so he did the longest side alone, right? Equals 15 squared.
And then
So did you notice they weren't put in order? You gotta think about the order, right? So this is 81.
plus 144 equals 225.
Okay. So Naya, you were asking why do I add them? Because right away, to really figure that out, most people are gonna need to do the next step of addition, right?
Yeah.
So that's why you always wanna get in the habit. When you add 81 to 144, you do get 225.
Yeah, I did that.
Okay. So they're not always as obvious as the first examples. So it's just habit. So we would say yes to this one. Okay, I'll put a Y there for, well, yes. Okay. So for part B, That was A, right? Let's kind of shrink that up. Okay, so for B, what's the longest side? Yeah, half. Right, so how would you set it up? 1 squared plus 1 squared equals the square root of 2 squared, right? And what is the square root of 2 squared? 2, right? So 1 plus 1 equals 2, true or false? True, right? So we say yes, this one is true because 2 is equal to 2. What about the last one? Who says no? Okay, Allie, what'd you do?
I did 3 squared plus 4 squared plus 6 squared.
3 squared plus 4 squared is equal to 6 squared, right? So is it? So this is and 30, and 9 and 16 make 25 and 36? Not equal, right? So no. Okay, you understand how to tell something's a right triangle? With the rule or with the picture? Yeah? Okay, so now, can you find the missing side? And actually, I want to switch the order a little bit here. Let's do this one first. Now you know it's a right triangle. So you're told it's a right triangle either by the picture or by the writing or sometimes by both. So now you assume the Pythagorean theorem works.
Is it gonna work with all of them or not?
It has to if it's a right triangle. So if you're told it's a right triangle, the Pythagorean theorem always works, right? That's what it's. So we would say the hypotenuse is which one? In this picture. C, so we're going to put that over here. And this is 16 squared plus 12 squared. Remember I said it's really handy to know your perfect squares because you're not going to have a calculator. So, and it's way quicker than working them all out. Jason.
I know it's
So what's 16 squared? Why don't you start in with that?
16 squared is
256, right. 16 squared is 256. Okay, better with my left hand. 12 squared is what? 144. So when I add 144 and 256 together, I get 400?
Yes.
Okay, so Jason, what are you going to do with that 400? You find the square root. Okay, so this we talked a little bit about, but you maybe don't remember the symbols. The way you show you're finding this, you're going to take the square root of both sides. You're undoing both sides. It's just saying to the person reading your paper, you're going to get the square root. So that means you're going to be able to tell me what C is, and that's 20. That's kind of what your homework's like.
why you
Because you're looking for what number times itself is 400. You're looking for the length of C, not the area, the square. So look at the 2 pages here. Here we started with lengths, right? And then we squared them. Now we're trying to find the length, so we have to undo the square. 20 times 20 is 400.
oh
Yeah, you're supposed to know your square roots from 1 to 25, your perfect squares.
I just don't
Yeah,
I thought you said 20.
well, probably, I'm going to say 25, but you have till what, Tuesday?
Yeah.
Start memorizing. Okay, real quick, you guys. before you, they're not hard to, you know, we went through this yesterday, right? You know many of them already. It's really in your best interest because you use them all the time. So, and remember we practiced even hard ones like the square root of 961. We practiced like, you know it has to end in a 0, right? So if it's not a perfect square, you would do an estimate. But right now we're just working with perfect squares. Okay. So what's the difference between the second problem and the first problem? Raise your hand if you can tell me, Naya.
You already have the hypotenuse.
You already have the hypotenuse. So how do you set it up, Naya?
So you do 13 squared, which is 969. And then 12 squared plus a.
So 13 squared is equal to 12 squared. In this case, it's x, but it's the same thing. X squared. Do you guys see how to set that one up?
Yeah.
Now the variables on the other side,
Can you
like
just keep it a square?
you could, but the problem says it's x. It doesn't matter. You're going to see different letters in different books. So this is 144. Do you see that?
Yeah, so you just have to add it to 169, and that's 25 squared.
Yeah, so you're now solving an algebra problem like we did in the beginning of the year. You subtract 144 from both sides. Oops. So subtract 144 using your algebra skills. Remember that? So we have 25 is equal to x squared. So now you take the square root of both sides because you want to know what x is. So you're just, that symbol is saying I'm finding x. So now we write x is 5. You get that? Okay, so that's about it. I'm going to post these notes and I'll post